Hello everybody, today we'll talk about optical switching. It is recommended to have prior knowledge about basic optics and switching networks in order to better understand this topic. Let's begin now. First, I will talk about optical fibers. As you can see in the picture, optical fibers consist of the outer covering or buffer. Then we have core and cladding inside, both of which are made up of glass. Advantages of optical fibers mainly include faster communication, good insulation unlike electronic components. Number 3, it's safe from noise and interference. And lastly, there occurs lesser attenuation also. The phenomena that works in the principle of optical fiber communication is total internal reflection. I'm assuming all of you have basic knowledge about it already, or else you can study about it. Moreover, optical fibers can work both in single mode or multi-mode. So using optical fibers, you can send single wavelength beam or also a multiple beam. So what is optical switching? It is more or less similar to circuit switching, but wire links are replaced by optical fibers. Another point to be noted is packet optical switching is also possible, but it's very complicated. Now, why is there a need of optical switching? Number one, because it's fast. Number two, it's environmentally friendly as it consumes lesser power. And number three, it's secure. But there are some demerits also, like it can be very expensive. But important thing to remember, optical switching occurs at physical layer. Usually, optical fibers has a speed of around 40 terabytes per second, but optoelectronic speed is only 100 gigabytes per second. So how do we use it all? Answer is wavelength division multiplexing. In wavelength demultiplexing, number of different wavelengths are combined together and then transmitted through a single fiber. On the receiver side, we have a demultiplexer which separates different wavelengths from each other. So, how switching can be done optically? Answer is using MEMS, that is microelectronic mechanical systems. Here you can have a look at how MEMS switches look like. First one is a two-dimensional descriptive as well as real picture. Second one, the three-dimensional picture, explains how it works. In microelectronic mechanical systems technology, number of very small mirrors are etched over a silicon chip using photolithography. Using MEMS, all wavelengths, irrespective of its length, can be switched. Mirrors are placed very precisely in order to give efficient results. Currently, around 256 to 1024 mirrors are implemented on a single chip. Next, we'll talk about multiplexing and demultiplexing techniques used in optical switching. Basically, we have an optical add-drop multiplexer, using which any unwanted wavelength can be dropped or any new wavelength can be added anytime during the transmission. You can see that in the figure as well. Let's now talk about how demultiplexing can be achieved. There are a number of ways. Number one, using refraction. Optical fiber beam is passed through prism which splits different wavelengths differently. Using diffraction, in which a wave encounters an obstacle or a slit. Thirdly, using interference. Here, light is split into different waveguides which have different lengths. Now I will talk about how a switch is constructed. A splitter, a combiner, and a filter is used. Each input is split between N outputs, which are amplified using EDFA as a filter. Remember, combiner has only one active input. At the end, let's get to know something about optical packet switching. In optical packet switching, packets are optical signals. But for control information, optical to electronic and then back to optical conversion is required at interface. So there are large overheads also. Routing information can be extracted by converting control part, that is header only. Payload is left untouched but passed through fiber delay line. That would be the end of this lecture. I hope I'm able to cover some important topics related to optical switching. Thank you.